Just like fingerprints, digital signatures are unique to a single person or entity. These signatures are mathematically derived from a special pair of numbers that we discussed in the previous module, a public and a private key pair. A signature on a public key can only be created by the holder of that corresponding private key. Just like a real signature, a digital signature should convince the recipient that the message underlying is authentic. What is a protocol? A protocol is a set of rules or procedures that govern a system. Whether that system is a computer network, a town hall meeting, or a board game, anything. For instance, in chess, individual players may have their own strategies, but the way in which each of these chess pieces moves on the board is dictated by the rules of chess. That is the protocol. In networking as well, a protocol is a common program executed by multiple computers on the same network. These networking protocols govern the transmission and handling of information as well as execution of programs between these interconnected independent devices. As I told you, the TCP protocol, the Transmission Control Protocol, represents one of the most foundational protocols for managing various packets of information as they travel across the internet, powering applications like the World Wide Web, email, media streaming, videos, and etc. So in the internet, we have the TCP IP. In the same way, in the crypto protocol, we have the consensus protocol. This protocol followed by each network participant called a node to create a single shared state of the blockchain. In this context, imagine consensus protocols replaces centralized record keeper or counterparty, enabling trustless peer-to-peer interactions. In a classic centralized client-server network, data is requested by one class of computers known as clients. They can be mobile phones, PCs, etc., and is served by another class of computers called servers. Facebook is a good example of a client-server network. Facebook profile data lives on Facebook servers and is sent to the user when they open the app on their phone. This hub and spoke model is a highly efficient but brittle system since the server is a choke point and centralized point of failure. Contrast this with a peer-to-peer network where the connections resemble more of a spider web. In a peer-to-peer network, each node operates under single communication protocol to transfer data between them. This model is often less efficient but much more resilient because there is no single point of failure. Perhaps the most famous example of peer-to-peer network is the internet itself. The consensus protocol is similar to the operating system of a blockchain, but blockchain consensus algorithms are special because they define how to resolve disputes between various nodes that might receive conflicting data. Think of a consensus algorithm as a digital, impartial judge that hears both sides of an argument to arrive at the truth of what actually occurred. This judge then determines how to proceed according to a set of predetermined laws or rules. These rules should ensure that they have three properties. One, liveness, which ensures that the data can always be added and the network never gets stuck. Second, agreement. All the nodes in the network eventually agree on the same value. And third, most importantly, safety. It ensures that an agreed upon value does not violate the protocol itself. So research has shown that it is impossible for networks to be truly distributed, truly permissionless, and to achieve all three of these properties. This means that blockchain designers face trade-offs about what to prioritize. Consensus algorithms aiming for high speed often limit the number of participants, making it less decentralized. So you have fewer participants but very fast network. On the other hand, protocols that prioritize decentralization and failure prevention tend to be slower and less performant. So what happens is, it depends on you, the blockchain providers, to ensure that whether you want to be decentralized completely with a lot of nodes or be extremely fast with a centralized node. These kind of networks build their own protocols, and you have the choice to use whichever protocol might be the best for you. In the next module, we'll talk about why decentralization matters, and we'll try to solve a case study.